Hello guys, the learning outcome of today class is how to plot the given function in terms of the POS function, not folding method, how to plot the given function in terms of the POS function. So as per in previous lecture, so if you observe clearly, so whatever the problem we have solved, either it may be 2 variable, 3 variable, 4 variable, and even using don't care combinations, we have done for only SOP function, right? I repeat that SOP function means representation of the output 1, POS function means representation of the output 0, right? Now question is something like this. SOP means, as we discussed earlier, we will be having the min term combination, then some min term value. In case of don't care combination, we will be having the don't care values, right? Now question is that we need to solve by using of the POS function, right? By default we are plotting the K-map solution for the SOP function, right? Now if you observe here, the given question is in terms of the product term value, right? Product term means this is the product term, these are all called as the sum term. For example, see if you take 0, what is the value of 0 in POS? A means what we have to write, right? We need to write 0. A bar means we need to write the 1. So what is the meaning of this one? A bar plus, right? 0 means the value is something 0, 0, 0, right? So 0, 0, 0 means what is the answer? A plus B plus C, right? So if you observe this, these all are the sum term, right? It means 0 is the sum term, then 3 also will be some term, 4 will be some term, like that, right? So what is the POS means? We will be having the several sum terms, right? So which are going to be, what we are going to do? We are going to multiply together, right? So multiply means here we will be having the product term, right? That is the reason why we are writing the product term to represent, right? So then what is the meaning of capital M? Capital M is the max term representation in the POS function, right? Now how to solve the POS problem means there is no direct solution. Even we can find the simplified answer directly, right? So by using the POS also, but here in this today's class, what is our intention is that we will try to solve the POS function also in terms of the SOP function, right? So what I am trying to say here is, you consider even if it is the POS function also, you can consider this as the SOP function only, right? What I am trying to say is, you treat this function as the SOP function, then go ahead, right? So solve the problem as we used to solve a real method, right? So now what I am thinking, right? I am considering this as the SOP function only. Now I am going to solve the problem, right? So what is the given max term, right? Just we will represent the, right, in terms of the POS, but we will solve the problem in terms of the SOP only, right? Now what is the max term we have given? 0, 3, 7, right? Remember in K-map, plotting of SOP means we need to plot the ones. The given function is POS means we need to plot the zeros, right? What is the value? First value 0, next value 3, right? 0, next value 7, right? 0, next value 4, one more is 8, next one is 10, right? Fine, 10, then 14, one more is 12, guys. Now we have the don't care combination, right? So what are the don't care combination? They are given 2, 6, 11. So 2, 6, 11 is the don't care combination, right? 2, 6, 11 is the don't care combination, right? Okay, fine, these are the things. Now what we have to do is, we need to perform the minimize operation. Let us assume that we don't know how to perform the minimization operation for the POS function. In this case, what we will do is, we will assume that these are also ones. Like that we will solve for the problem by using of the SOP function only. Then once it is SOP function is completed, then we will try to find the final answer in terms of the POS function, right? So try to assume that zeros also in terms of the ones only, then we will try to solve the problem, and finally we can convert the SOP function into the POS function. This point you have to remember, that is much important here, right? Now see that, is there any, first we will start from here, is there any 16 zeros grouping? You consider 0 means in terms of the 1 only, right? You feel it is SOP function, right? Is there any 16 possibility? No, right? Is there any 8 possibility? Try to look it properly. Is there any 8 possibility? Yes, we have 8 possibility. In which condition? This is adjacent of this one, adjacent, right? So again it is adjacent of this one, right? It means we can able to group the 8 groups at a time. But how to group it? So directly we cannot able to group these 8 zeros. How to group is? So by using of the folding method we are going to group. What is the meaning of this one? This part we are making into the 2 halves. This came up we are making into the 2 halves. Let it be this is the second part. This one is the first part, right? Now we are going to fold the second part on the first part. Once it is done, everything will be vanish here. You will be getting only first part. That is the meaning of the folding. We have discussed it so many times in the previous classes, right? So now this is one possibility. Now what is the answer for this one, guys? So after folding this one into this one, then what will be happen? Right? So this, now before that we need to consider this as 1, right? Then only we will be getting the 8 grouping. Now what is happening? This value is CD bar, right? So it will be lies here, right? So all these things will cancel, right? All these things will get cancelled, right? Now what is the product term value for this one? C bar get cancelled. D bar means D bar is the answer. For this, what is the answer? D bar is the answer. Now what is the leftover zeros? This one, you treat this 0 as the 1, you solve the problem, right? Now how to solve this problem? From this 0, is there any 8 possibility? No. Any 4 possibility? Yes, we have the 4 possibility, right? So I done one mistake, right? What is that mistake is, guys? Sorry for that. What is the mistake is that here this don't care combination is there, guys, right? This we need to treat it as the 0, right? We are trying to in terms of the POS function, right? Sorry for that. You consider this as the 0. Now see that if you start from here for this term, is there any 16 possibility? No, right? Is there any 8 possibility? No, right? Is there any 4 possibility? Yes. What is that combination? That 4 possible combination. This is the 4 possibility combination. Now what is the answer for this one? This product term, what is the answer? So B bar B get cancelled. A bar means one product term is A bar, right? So again in this direction. So what is this value? Something CD bar, right? So CD, right? D bar get cancelled. CC means C. What is the final answer we got, guys? One is D bar, another one is the, right? So D bar plus A bar C. A bar C. If you understand here why I wrote, yes, POS means some terms are going to be producted together, right? Here why I wrote something like product terms are going to be added together. The reason is that we assumed this 0 in terms of the 1, then we solve the problem, right? That point you have to remember, guys, right? We have solved the problem. So what is the answer we got? D bar, something this one like. So what is the answer? Let me go back. So D bar plus A bar C is the answer, right? First let me erase. So what is the answer we got is D bar plus A bar C, right? Just a second, stage. D bar plus A bar C is the answer. Now what type of function is it? SOP or POS? SOP function. Whatever the output we have obtained, right, for this function, it is in terms of the SOP. Now how to convert the POS function, guys? Because the given question in terms of the POS, but we don't know how to convert directly POS. We have the procedure, but as per we are familiar with the SOP function. So for that what we have done is, even though it is 0, we assumed that as the SOP function, then we completed the problem. So this is the answer we got for the SOP. But the given question output should be in terms of the POS function, right? Now this function should be converted into the POS, right? So this function should be converted into the POS. Now try to tell me what is the relation between SOP POS. SOP to POS is the complement relation, right? SOP to POS is the complement relation. The relation is SOP to POS is the complement relation, right? Now what is the meaning of this one? So whatever this expression, if you want to find out the POS, just whatever the expression we got, something D bar plus A bar C, right? So for this just you apply the complement value. Now it is in terms of the POS form, right? Now if you want to if you want to find out the answer further, then here we have the whole complement, right? Whole complement means we need to apply the De Morgan's theorem, right? We need to apply the De Morgan's theorem, right? What is the De Morgan's theorem, guys? A plus B whole bar equal to, the second rule for De Morgan's law equal to A plus B whole bar equal to A bar into B bar, right? So now you consider this value is the something like this. This value consider as the A, this value consider as the b. Now apply this formula, a plus b whole bar equal to, what is that value? A means d bar, right? D bar whole bar, right? So here it will not be plus, it will be into, because here a into b bar into, so what is the b value we assume? B. Why we are assuming this d bar is a bar c as b means, but we are familiar with this formula, a plus b whole bar equal to a bar into b bar, right? That why we are assuming this one as the b, this one as the a. Why means we will try to convert everything in terms of the a plus b whole bar, so that it will be easy for us to find out the a plus b whole bar equal to a bar into b bar, right? Now what is the b bar value? A bar, right? What is the b bar value? A bar c whole bar value, right? Now what is the answer for a bar whole bar? If you understand, a bar whole bar equal to what will be happen? A is the answer, right? Here d bar whole bar equal to d is the answer, right? Dot. Now if you see here, again we have the whole complement here. Again we have the whole complement here. Whole complement means what rule we need to apply? One more time, De Morgan's law, right? So this is something look like a bar c, right? This is something look like a bar c whole bar. This you consider as the a, this you consider as the b, right? So like that we need to solve the problem. This you consider as the a, this you consider as the b. Now what is the answer for this one again? Right? So let me arrange so that I'll get some space. Just give me a second, guys. Now fine, what is that value we got? Right? So one is d bar dot a bar c whole bar. So for this you apply the De Morgan's law. Now what is the answer? D bar dot, right, a bar whole bar plus c bar, a bar whole bar plus c bar. I'm not getting space here, so that I'll write here d bar plus, sorry, d bar dot what is that value? A bar whole bar plus, what is that value? C bar. This is the value we got, guys. Now a bar whole bar equal to a, right? So d bar into a plus c bar, d bar into a plus c bar. Now see that this is the sum term, this is the another value which we are going to make the product. So this is the final answer in terms of the POS function, right? So this is the final answer in terms of the POS function. If you feel that this is too much complex, I have the shortcut for you guys. So I'll tell you what is the shortcut. So just remember the, after came of minimization, what is the SOP function we got? The SOP function we got is the, right, what is that SOP function? D bar plus a bar c is the SOP function, right? So let me take one more thing, right? What is the function we got? Something like this, right? D bar plus a bar c. This is the value we got, right? So this is SOP. If you want to find out in terms of the POS, so what we have to do, we need to perform the complement. We have the shortcut, guys. You don't need to remember the De Morgan's law and apply also. Simple thing, right? If you have the complement, just try to remember the rule is, if you have the complement, you remove the complement. If you have the complement, you remove the complement, right? First rule is that if it is complement, you remove the complement. If there is no complement, you make it as the complement, right? Then one more, if you find the plus, you replace with the product term. If you find the product term, you replace with the sum term. Simple thing, guys. If you find the complement somewhere, you remove the complement. If you find the normal variable, you make it as the complement, right? Then if you find the plus, you make it as the product term. Product means you make it as the multiplication. If you find the multiplication, you make it as the plus. Now see that what will be happen. D bar means what we have to write? If it is complement means we need to remove the complement. So here plus means what we have to write? We need to write the multiplication term. So a bar means what we have to do? We need to remove the complement. So if you observe here, what is this? A bar into C, right? C means product term, right? So product term means what we have to write? Product term means we need to replace with the plus. C means what we have to write? C bar we have to write. See, earlier after applying the De Morgan's law, we got this answer. Now if you remember this shortcut, plus to product term to plus, complement to uncomplement, uncomplement to complement, then you will be getting the direct answer, right? So let me conclude what we have done in this problem is, the given question is in terms of the POS function, right? So one thing is that if you make the complement of this value, this question, right? if you make of the complement of this value, then if you convert something in terms of the ABC, first we need to write in terms of the SOP function, then we need to find out the complement, right? Then we need to convert this function, will be converted into the SOP form, then you can perform. It will take some time, guys. So for that reason, what I am trying to do is, so whatever the function they have given, so just I am plotting in terms of the zeros only. In K-map, in terms of 0 only I am plotting. So but how I am treating means, I am considering treating these zeros as the ones. So then I am finding the answer in terms of the SOP function, right? You will be finding the answer in terms of the SOP function. But if you see that output should be required in terms of the POS function, for that what you have to do, either you can perform the complement of the SOP, and you need to apply the De Morgan's theorem, so that you will find the final result in terms of the POS function. Or I have given some shortcut that will be very helpful. If it is complement, you remove the complement. If not complement, you make it as the complement for the variable. If you find the product term, you replace with the sum term, means plus, right? If you find the product term, means dot, right? If you find the dot, you replace with the plus. Just to apply, you don't require to apply the De Morgan's theorem, right? So we have completed how to convert the, right, how to solve the K-map by using of the POS function, right? I hope you understand, right? If you like this video, please try to like and share them, right? So that will be easy for me, means not easy, it will be helpful for me to create some more videos. Thank you, guys.